What we're going to do now is use trigonometric substitution to solve this. We're going to use trigonometric identities to get this to look like a standard integral, which remember is a whole point. I want it to look like one of those things you've got on your table of standard integrals, and then we can do it. And you've got a list of trigonometric identities here. And so we're going to use some of these to try and work this through. We know that cos squared theta plus sine squared theta is 1. That's one of the trigonometric identities we had there. And we also know from our table of trigonometric identities that cos 2 theta equals cos squared theta minus sine squared theta. Cos squared theta minus sine squared theta. So we can end up with a really useful identity here. We can combine these two. If we look at our integral, we want cos squared. We want to get rid of that. And if we look at that, if we look at this identity, we've got a cos squared in there, but also cos 2 theta. I wouldn't mind that because that's a standard integral. I could do that one if it was that. So what I want to try and do is replace this with something in terms of cos 2 theta. And so I look at it and I say, okay, that's cos squared theta, so that's like this, but I want to get rid of this. I can rearrange this one in terms of sine squared theta. I can write sine squared theta equals 1 minus cos squared theta from this top one. And then, instead of sine squared theta in here, I could substitute that in and then rearrange it for cos squared theta. And so I then have cos squared theta equals something, hopefully with just this in, which is a standard integral. So I'll run this through, but I'm just going to pause this here now and just see if you can work that out. What I want to end up with is something with cos squared theta equals something else in terms of this. So just see if you can do it. So looking at this one here, this second one, I want to replace this sine squared theta with something. So looking at the top one, sine squared theta equals 1 minus cos squared theta, right. So now substitute that into the second one. We can write cos 2 theta equals cos squared theta minus 1 minus cos squared theta. I've substituted in that instead of sine squared theta. Yes, thank you. Yeah. Be a little bit careful with signs here. I'm minusing each of these terms inside this bracket, so just a little reminder of basic algebra ideas. Minus 1, but minus cos squared theta. So I end up with that equals cos squared theta plus cos squared theta, which is 2 cos squared theta minus 1. Write that down and just pause and check you see that makes sense. Just look at this for a second, what we've just done, and think about it. If we look back at the original integral, I wanted to get rid of the cos squared theta. So I've now pretty well got something in terms of cos squared theta, which I'm going to rearrange in a minute in terms of that, which is going to be easy. I could just as easily have had an integral that involved sine squared theta, and it would have been a very similar idea, wouldn't it, to end up with something involving sine squared theta rather than cos squared theta. I would have just eliminated the cos squared theta in here rather than the sine squared theta. So a similar steps would have allowed me to integrate something involving sine squared rather than cos squared. So completing this, I'm going to take the 1 over the other side and divide by 2, so I'm going to end up with cos squared theta equals 1 plus cos 2 theta all over 2. Right. Which I could write as a half of 1 plus cos 2 theta. Either way. You know, I'm trying to remind you all the time about these different ways of writing things algebraically. So now looking back at the original integral, I can replace it with 2 times a half 1 plus two, sorry, 1 plus cos 2 times 4t dt. Don't need that bracket there. I'm replacing cos squared theta with a cos 2 theta note, so I'm doubling the angle. And so we end... Oh yeah. Well, I can do a bit of simplifying. 2 times a half is just 1, so they disappear. These two cancel each other out, and 2 times 4 is 8, so I can call that 8t. So I end up with integral between 0 and pi over 4, 1 plus cos 8t dt. And suddenly that looks like a much more straightforward. I can now integrate that because they're just standard integrals. Now I can finish off and integrate this. So I integrate 1 with respect to t, I get t. And I integrate cos 8t, cos becomes sine, and divide by the number. So it'll be sine 8t over 8 between 0 and pi over 4. Pi over 4. So that goes inside a square bracket. And now I just replace t with pi over 4. So that will equal pi over 4 plus sine 8 times pi over 4 is 2 pi over 8 minus 0 plus sine 0 over 8.